Hi, folks. So my name is Brad Pino. I'm Associate Professor of Silviculture at the University of Alberta in Edmonton, and it's my pleasure to welcome you to the Silviculture of the Boreal Forest of Northern Alberta. What I want to do today is give you a quick kind of tour about what does silviculture look like in my part of the world. So what are we doing for silviculture here in terms of operational silviculture? I also want to talk to you a little bit about some of the other types of silviculture, more intensive silviculture, focusing on timber production, and a little bit on more ecological silviculture, focus more on mixed forest and other forest values beyond timber. But before we get started, I just want to do a quick thank you for the partners that we have in kind of making some of the research work that we're doing here possible. So, West Fraser, Alpac, Canfor, Vanderwell, Miller Western, Weyerhaeuser, Forest Resource Improvement Association of Alberta. They've all been sponsors of my research and many others' research at the University of Alberta. And really, without our partners, we're not able to do some of the great things that we are able to do here in terms of our research world in particular. So anyways, quick thank you to that. Also, thank you to Ethne and Joseph here who are helping me film. I wouldn't be able to do this by myself, and I'm hoping they're going to help with the editing too. But anyways, so what I want to start with here is this is an operational clear cut in beautiful northern Alberta. We have an amazing view behind me here of the foothills of Alberta. So this cut block was harvested about 3 years ago. This is a clear cut. The standard practice in forestry in Alberta and across much of Canada is essentially clear cutting. So this site was clear cut, and the regeneration treatment was planting pine. So this is a lodgepole pine. It was planted. This is its third growing season. It's doing really well. So the site was planted with pine, and then the aspen that we're seeing. So this is aspen around here. It's naturally regenerating from root suckers. So this is the kind of the standard regeneration practice for aspen is leave for natural regeneration from root suckering. So clear cuts are the standard forestry silvicultural practice. So a couple of things I want to point out about clear cuts here. So the harvesting system we've got is feller bunchers, grapple skidders, drag the trees to roadside. There's an old road just starting behind me here. At roadside, the trees are processed, so the tops and limbs are cut off. That results in fairly large brush piles. So behind me here, we have an old brush pile. What happens with those is they are burnt. So in the following winter, or the 2 winters after, those piles get burnt. And the idea is to reduce the amount of fuel loading the block and also to reduce the slash in terms of enabling some of the silvicultural treatments. And then those areas are planted. You can see the pine trees that have been planted right through it as well. So that's one of the features of our standard silvicultural operations. Something else we're kind of seeing in the background, you can see a patch of leaf trees back there. We are dealing with crown land, and so there are rules in place in terms of harvesting, and one of them is around structural retention in cut blocks. So on average, the general practice is about 3% of the trees are left in cut blocks. Maybe not in every cut block, but across the landscape, about 3% retention. And that's some in patches like we see behind us. And then there's also some individual trees across the cut block as well. So, but when I think about that, those are done for ecological values, not necessarily for silvicultural values. And what I mean by that is the trees that are left behind are not there to provide shelter for these sites. So this isn't a shelter wood. They're not done to provide seed for the site in the future. So it's not a seed tree system. It really is a clear cut system. The trees that are left behind are left for other values, whether it's wildlife, whether it's biodiversity, whatever the case may be. But that is, that's part of our system as well. So, that's a quick introduction to silviculture in Alberta. This is a standard operational clear cut, and we'll see a couple of other examples as we move forward. Hi, everyone. So here we're going to be talking about boreal mixed wood management. So what I mean by boreal mixed woods are trembling aspen and white spruce growing together. This is a very common forest type here in Alberta. Much of our forest we refer to as boreal mixed woods, and that can mean anything from kind of pure aspen stands to pure spruce stands and everything in between. So we're at the Judy Creek mixed wood experiment right now, and this is an experiment that was established 22 years ago by Phil Como and colleagues out of the University of Alberta, but looking at ways of growing mixed woods, growing aspen and spruce together as mixed woods. And the term that we would use would be intimate mixed wood, but actually, a really mixed species stand of aspen and spruce. So the way kind of operational silviculture works in terms of species composition in Alberta and really across much of Canada is whatever gets harvested is what gets replaced, right? So if you harvest a spruce stand, it gets regenerated as a spruce stand. Aspen gets regenerated as an aspen stand. Mixed woods get regenerated as mixed woods, so aspen and spruce together. The challenge is that's quite a bit more challenging to do, right? We're pretty good at establishing spruce stands, pretty good at growing aspen stands. How do you grow those two together? So what we've seen a lot of in the past is kind of growing two separate stands. So a cup block gets harvested, clear cut harvesting, come back in, regenerate half of the cup block to spruce, half the cup block to aspen, and as a whole, that kind of meets the definition of a mixed wood. And it might, in terms of our regulatory regime, it probably doesn't in terms of the spirit of mixed wood management, of growing the two species really side by side and having more of those interactions. So this experiment where we're at today is an attempt to show what's possible in that range of establishing intimate mixtures of aspen and spruce. So here what we're going to see today is we've got everything from pure aspen, like this stand over here. Behind me is a pure spruce stand. And over here we have different varieties of mixed woods. And we're going to talk about kind of the establishment treatments. So aspen establishing from natural regeneration from root suckers after harvest. The spruce was all planted, and then there was some spot herbicide treatments. So talking about the regeneration treatments. We'll also talk about some of the different stand tending treatments which were done, which essentially was thinning of the aspen and some of the benefits of those different treatments. Okay, and so what I want to talk about here was the different regeneration treatments, in particular for spruce. So what happened here is this stand was clear-cut harvested, the aspen regenerated from root suckers, and the spruce were planted, but there were no further follow-ups or other establishment treatments for the spruce. So in terms of the aspen, what we saw is after harvest, this stand regenerated to approximately 100,000 stems per hectare, very, very high density. And now we're 20 years later, these stands are just over 10,000 stems per hectare of aspen. So already 90% of the aspen has died, but this is still a very, very dense aspen canopy. You can see a lot of dead aspen stems where we're standing here. In terms of the spruce, this spruce is the same age. It was planted at the same time. So a 22-year-old spruce here, not doing very well. It is surviving. Spruce is shade tolerant. It can survive in the understory of spruce, or understory of aspen, sorry, but it's clearly not growing all that well. There's also, around me here, there is a fair number of dead spruce seedlings as well. So what I want you to do is kind of keep in mind as we're looking at these different establishment treatments, these spruce are all the same age. They're all planted exactly the same day. The difference in their growth is the environment that we're creating for them. This is probably the most competitive environment in terms of the really, really dense, high-density aspen stand we're in. Okay, so what I want to talk about here is just kind of the next step up in mixed wood management. So keep in mind the size of the spruce trees between the one that we just saw, which was where it was planted in the just pure aspen, but no treatments. What we've got here is the spruce had a competition control treatment soon after planting, where there was a 2-meter radius around the spruce trees was controlled of competition using herbicides. So, and you can still see that here right now. As you can see, a 2-meter radius around the spruce tree is clear of aspen competition. There's some other stuff growing in there, but there's no aspen. You can still see these circles in the forest here today. Things to keep in mind, where there wasn't those treatments, where there wasn't the establishment treatment, the trees were about this tall, and now they're quite a bit taller, right? So these trees were all planted the same day, but just look at the difference of doing that spruce establishment treatment. We've got much, much more productive spruce trees. In this particular site, there hasn't been a stand tending treatment of the aspen behind us, so you can still see it's relatively dense aspen in the surrounding matrix, but the spruce trees are still growing reasonably well because they had that establishment treatment of the 2-meter radius competition-free zone around them. Okay, so the next step up here was in terms of our silvicultural treatments. We've got just planting spruce, then we've got this the competition control, the spot treatment around the spruce trees, and then the third one is the thinning of the aspen matrix, and that's what we've got here. So we've got the spruce tree here. This tree did have that 2-meter radius of competition control around it. And then at age 12, what happened is the surrounding aspen matrix was thin, in this case down to 1,200 stems per hectare. And some of the response that we're seeing is again, bigger spruce trees. Remember, all the trees here are exactly the same age. but we're seeing bigger spruce trees, particularly in the diameter, and we're also seeing larger aspen trees. So both the spruce and the aspen are responding to the density that's happening in these stands. Okay, so what we've got in this treatment is this is a complete competition control. So here, all of the aspen was controlled with herbicide, not just spots around the spruce trees, but a complete control of aspen. And what we're seeing is we've got a pure spruce stand. So this is the one extreme of pure spruce stands. We've seen some pure aspen stands. This is the pure spruce stand. What we've got in terms of spruce productivity is these trees are the largest. The highest productivity for the spruce is in this treatment with no aspen. Just in terms of some general numbers, at age 20, the average diameter of spruce in these stands was around 12, compared to around 8 in the mixed wood treatments and around 2 in the aspen treatments with no establishment treatment for the spruce. So really, all those trees are exactly the same age. The difference is the growing environment we're giving them, and the trees here are growing best in terms of the spruce. Of course, there's no aspen. So now the question is, how would we manage these stands? We have lots of stands like this. In terms of what in the future, is there a commercial thinning or something along those lines? Probably needs to be considered now, because we are starting to see a lot of competition between the spruce trees already at this stand at this stage. Okay, so at this spot, I just want to talk a little bit about some of the other research that we're doing here at Judy Creek. So most have been focusing on kind of silvicultural treatments and the timber side of it, so density, MAIs, that sort of stuff. But we're also doing a bunch of other research out here as well. So what we've got here is an environmental monitoring station, light, soil moisture, soil temperature, air temperature, all of that sort of stuff. One of the questions with this we want to look at is, are lower density stands, is there more soil moisture available? Is that making those forests more resilient to drought? Future climate change projections, this is a part of the forest we're expecting to have more frequent, more severe droughts. What can we do to create stands that are more resilient? So that's one of the questions that we're looking at. We've also looked at other things, looking at understory plant communities. So what's the impact of the different canopy compositions on the understory plants? So beyond just trees, I'm doing the same sort of thing with soil nutrients. So what's the impact of the different silvicultural treatments, the different compositions on soil nutrients? And what we're seeing is, as we get progressively more spruce in the stands, there is some differences in some reductions in nitrogen availability and changes in pH and things like that, which might have some longer term implications as well for these sites. But the idea here is that, as with many studies, we started out focusing mostly on timber, and we're also trying now to incorporate some other ecosystem values into the research. Other things, I think some future potential is here, looking at what's the impact of these different stand compositions on fire risk, fire hazard, or some more hazardous than others, and potentially also looking at wildlife habitat values in these different stand types. All right, so now I want to talk about the different tending treatments that we've got here at the Judy Creek Mixed Wood Experiment. So we've seen the establishment treatments for spruce, followed that up at age 12 in the mixed woods with different thinning regimes of aspen. So in the mixed wood treatments, we had thinning, either kind of an unthinned control. We also had thinning then down to 2,000, 1,200, and 800 stems per hectare of aspen. Over on this side, this is 1,200 stems per hectare of aspen. And on this side, we've got 800 stems per hectare of aspen. You can see some differences in terms of the growth of both the spruce and aspen. You can see that the aspen in the thin stands were the trees on average are clearly bigger, and the spruce are also larger in the thin stands. The trade-off, of course, is that there are fewer of them, right? So, across all of the treatments, I also want to talk a little bit about some of the general timber productivity here. So, some of the modeling that's been done here across all of the different treatments, the MAI, or the average site productivity, is essentially the same at about 5 cubic meters per hectare per year. The difference between treatments is how much of that productivity is in aspen versus how much is in spruce. So we can go from everything from pure aspen to pure spruce. The total productivity stays essentially the same, but we kind of got a slider of how much aspen and how much spruce. And the more intensive treatments that we're doing, the more we're getting more spruce volume and less aspen volume. For example, by planting spruce, you get a little bit of spruce volume. By doing the establishment treatment with the the spot applications, we're getting a little bit more. And now by doing the thinning of aspen, we're getting even more productivity of spruce coming out. So just kind of showing the potential of being able to figure out what kind of stands that you want and the different treatments that are needed to get to those different outcomes. So one of the things that I've been doing, I bring a lot of people to this site here. I really like it. But one of the questions that we always kind of talk about are, what feels best to you? So if we're looking at managing mixed woods, what feels best to you? And there's no numbers involved here. We're not quantifying it. It's more of a gut feeling thing. And I think in general, these are the two treatments that aspen and spruce mixed woods, kind of thinned aspen to 1,200, 800 stems per hectare. These are the ones that people like the most. And that means different things to different people, but I think it's also important that, you know, forestry and silviculture isn't just about numbers. It's not just about MAI. It's not just about timber productivity. Forests are also about what they make us feel. And this is part of it. I think this is one that we have to be thinking a little bit about in when we are making silvicultural prescriptions. So the last bit that I want to talk about here is, what are the next steps? What do we need to do in terms of to operationalize these sorts of treatments? This is an experimental site, and what I think we've got here is we've shown the potential, we've shown what is possible in terms of mixed wood management. We are not seeing this exact kind of treatments replicated in terms of the operational land base here, but we are seeing people starting to get into this idea of actual mixed wood management and trying to grow intimate mixtures of aspen and spruce. So what are the actual treatments going to be? I don't know, but I do know that there's going to be we can talk about these different treatments. There's probably going to be an establishment treatment. So aspen regenerate naturally from suckers after harvest. Spruce will need to be planted. Probably need some sort of an establishment treatment for spruce. We can't just plant spruce and hope it's going to make it. It'll probably survive, probably won't grow great, right? So needs an establishment treatment. Maybe that's a spot tending treatment. Maybe that's a spot application of herbicide or something else. Maybe it's a site prep application, but there needs to be some sort of an establishment treatment. Probably also need some sort of a follow-up tending of aspen. If we want to maintain some reasonable spruce growth rates, I think what we need to do is some sort of aspen thinning. We're getting an aspen response to the thinning. We're also getting a spruce response to the thinning. But I think that's a lot of steps. That's more silviculture than we do in most mixed wood stands. And that's some of the challenges, is how do we manage these stands which that are meeting a range of different values, but it's going to be more complicated silviculture, more involved silviculture, potentially more expensive silviculture. How are we going to operationalize that? And I think that's really the question for our silviculture community now in Alberta to start thinking about is, okay, if this is the type of forest that we want, we've seen what's possible. Now, what are we going to do to get there? And that's, I think, our next phase of where we're going in terms of kind of taking the research and expanding it across the landscape. All right, so we're in a lodgepole pine stand now. We're going to talk a little bit about commercial thinning and pine management. So just a little bit of history of lodgepole pine. So lodgepole pine is a serotinous pine. It's an early successional shade-intolerant conifer. One of the unique features of it is that serotinous cones. And what I mean by serotinous cones is the cones are essentially glued shut. Just kind of zoom in there. You can kind of see that is just from the tip of a branch here. So it's an aerial seed bank on these trees. So naturally what happens is a fire will come through here, will burn the heat from the fire, will melt the glue holding the cones together, the seeds will be released and we'll get a new forest afterwards. So it's a very fire-adapted species. We're able to use some of those characteristics in our silvicultural system for natural regeneration of pine after harvesting, referred to as drag scarification. So history of this stand, this would have been harvested. It's approximately 40 years old now. But it would have been harvested and then drag scarified for natural regeneration of pine. So what drag scarification is essentially, it's a type of site preparation which spreads out the slash across the site and also exposes some mineral soil as well. So refer to it as shark fin barrels, which kind of spin as the site preparation, kind of creates little scalps of clearing away the organic material, exposing the mineral soil below. And then also anchor chains, which drag the slash and the cones across the site as well. And then what happens is the cones get placed on the exposed mineral soil. In the summer, that heats up to quite high, greater than 50 degrees Celsius. And that's hot enough to melt the glue holding the cones together, the seeds are released and we get natural regeneration. So historically, this has been a kind of a very common silvicultural system for natural regeneration. It works particularly well on lower quality sites, on more sandier sites is where we've seen it in the past, and we still see it quite a bit today. But anyways, that's a little bit of the history of Serotinous pine management. What's going on here, one of the challenges often with drag scarification is quite high regeneration densities. So this stand was followed up with a pre-commercial thinning. And then after the pre-commercial thinning, we've now recently had a commercial thinning. So this stand was commercially thinned a couple of years ago, down to around 800 to 1,000 stems per hectare. And yeah, so this is an operational commercial thinning. There's not a research trial or anything like that, just an operational harvest block. So the goals of the commercial thinning, extract some volume now, but then also increase the growth of the remaining trees and be able to have a merchantable stand and a more valuable stand in the future. One of the questions when we started getting into this is we're just starting in Alberta into this realm of more intensive management, more commercial thinning, that sort of stuff. We're just starting this now. So there were a lot of questions. One of the questions was, while we're reducing leaf area in this stands, we're going to end up with lower volumes. And in general, that is kind of what we're seeing. But what we found through some of our research projects and other sites is when we add in the volume that's removed at the time of thinning, which is usually between 50 and 100 cubic meters that's removed at time of commercial thinning, and add that to the post-thinning growth and final harvest volume, we're able to extract more volume from the stands through thinning. And we are also able to get a more valuable stand because the trees that are left at the time of final felling are bigger, more valuable trees. So there's lots of benefits in terms of timber production for commercial thinning. Hi folks, so we're here in a spruce plantation talking a little bit about plantation management as we kind of do it here in Alberta. So quick overview of this site is 28-year-old spruce plantation. Really, this is a focus on timber production here. Some of the reasons that I think this is interesting to see is just it gives a demonstration of what the potential for plantation management here is in Alberta. We often think of forests and trees growing slow in the boreal forest, but they don't have to. Really, I think we can see that on some good quality sites with the appropriate silviculture, we can grow trees pretty fast. And this is a great example of that, really. So again, 28-year-old stand. I'm going to talk in general about kind of plantation management in this area rather than the stand specifically, but you get the idea, right? So these stands were planted at about 2,000 to 2,500 stems per hectare of spruce using whatever the best seedlings that we're able to get at the time. Followed up with a glyphosate application, 1 or 2 depending on the amount of herbaceous and shrubby competition. Many of the sites also had site preparation. The one we're standing in right now doesn't look like it did, but many of them would have had either some small mounds or bedding plow as well. Would have been a standard practice in many of these plantation forests as well. So kind of fast forward into the more recent activities is what we've seen in here is this stand was commercially thinned 2 years ago. So the way the commercial thinning worked is it was done with a harvester forwarder, which is kind of a unique equipment combination for us here in Alberta. We're starting to see more of it. But in terms of the trails, every 7th row was a extraction trail. So you can see on the side of me here, we've got an extraction trail there. And all the trees are removed along that. That's for the forwarder and harvester. And then the harvester can reach in 3 rows on either side of it to extract the rest of the trees that's going to be taking on in the thinning. So all the trees removed along the trails, and there was a thinning from below in the area surrounding the trails on 3 rows on either side. So what's the future of these types of stands? Really, I think we're kind of looking at 2 things here, is either another commercial thinning, maybe down to 500 to 600 stems per hectare in, let's say, 10 years from now, or we might be looking at just straight to a final felling in 15 to 20 years from now. So that's kind of what we're looking at in terms of the future management options for these stands. In terms of productivity, again, these are very productive forests. Our natural forests in much of the kind of the Boreal Alberta, we might be looking at MAI values of around 2.5 to 3 cubic meters per hectare per year. In many of these plantation forests, we're looking at around 8 cubic meters per hectare per year. So double to triple kind of the natural productivity. So one of the reasons I think this is really important is by kind of focusing on production on part of our landscape, that then allows us to do more ecological management in other parts of the landscape. So I think this is an important part of our forestry system for timber production, but also it allows more options both within the stands as well as across our landscapes. So the last thing I want to talk about here is some of the research that's going on with kind of plantation management in Alberta, but we're looking at one of the things that we're doing is switching from natural forests to these plantation or managed forests. And what we're finding is that our existing growth and yield models just really aren't working that great anymore. They're developed and work really well in natural forests, but as we switch to managed forests, we are seeing that they're not doing a good job of predicting growth anymore. Tend to be under-predicting the growth of trees in these types of stands. So there's a lot of work going on related to that. Robert Froese at the University of Alberta is leading a lot of that work. We're also looking at individual trees, so things like what's the taper of these trees? How are trees growing on plantations different than in our natural forest? So looking at things like the taper, looking at wood quality. You can see some of the branches on the trees around us here. Beyond kind of the timber side of it, there's other projects looking at some of the other ecological values that we're getting from these forests, whether it's kind of drought resiliency or whether it's understory plant community, whether it's carbon balance, other things like that. So, there's a lot of timber research going on, but also other ecological values from these forests. But really, I think the value of these forests is kind of demonstrating the potential for timber production in Boreal, Alberta, and this is just a great example of that. Thanks.